Aerofoil Terminology. The chord is a straight line joining the leading edge and the trailing edge. Thickness to chord ratio is the maximum thickness divided by chord. Camber is curvature of the camber line, the distance between the mean camber line and the chord line. Mean camber line is a line drawn halfway between the upper and lower surfaces of the aerofoil. It gives a picture of the average curvature of the aerofoil. Angle of attack alpha is the angle between the chord line of the aerofoil and the free stream airflow. Angle of incidence. This is the angle between the chord and the longitudinal centre line of the aircraft fuselage. Stagnation point. This is a point near the leading edge of the aerofoil where the airflow stops and the surrounding flow splits to follow either the upper or the lower surface. Aerofoil pressure distribution. Pressure gradient. This is a measure of the variation of pressure along the aerofoil surface. Air following the upper surface accelerates towards the area of lower pressure and reaches maximum speed at approximately the thickest part of the aerofoil, where the pressure gradient is maximum. Thereafter, it decelerates as it enters a region of adverse pressure gradient. An adverse pressure gradient implies that pressure is increasing as the air flows rearwards along the aerofoil upper surface. On the lower surface, air decelerates towards an area of higher pressure and then accelerates past this area. The overall result is a reduced pressure on the upper surface and an increased pressure on the lower surface, which gives a resultant upwards force, total aerodynamic force. Centre of pressure. The centre of pressure is a point along the chord where the total aerodynamic force acts, and for a subsonic aerofoil, it is typically located at approximately 25% chord. The total aerodynamic force can be resolved into two components, the one perpendicular to the relative airflow, which is called lift, and a component parallel to the relative airflow, which is called drag. Changing angle of attack. As the angle of attack increases, the stagnation point moves aft along the lower surface. Along the upper surface, the airflow heads towards an area with an adverse pressure gradient. When the pressure gradient is too large, the flow separates. This happens at a point called the separation point. As the angle of attack increases, the separation point moves forwards towards the leading edge. Critical angle of attack. If exceeded, a large portion of the airflow on the upper surface breaks away and the aerofoil stalls. Maximum lift is obtained just before the critical angle of attack. If the angle of attack is increased beyond the critical angle, lift decreases but drag continues to increase. As the angle of attack increases, the centre of pressure moves forwards and reaches its most forward point just before the stall. After the stall, the centre of pressure moves aft.